Hello everyone and welcome to our next lecture. So today we'll be discussing the HC05 module, and in just our previous lecture we were creating a Bluetooth controlled LED system where we have already created an application which is capable of connecting to the Bluetooth address that we have selected, and at the same time have the buttons on and off which will send the characters A and B. So all of that, the whole system, is quite clear to us at this point of time. And now what we want to do is we want to learn about the HC05 Bluetooth module and what are the pins available on it, how we can connect it with the Arduino Uno, and then write the code for this very system. So first of all, on your screen right now you can see what the HC05 module looks like. So it is a fairly small chip in size and it has 6 pins. So it has the enable pin, which is basically used to switch between the modes. So the HC05 comes with 2 modes. It has the data mode and the AT command mode. In the data mode you can receive and send data, and in the command mode you can actually change the settings of the HC05 module. So we'll be only dealing with the data mode, so this pin is not that useful to us. Also, one of the prominent things of HC05 module is that it can connect with other microcontrollers, other peripherals, and even smartphones using Bluetooth. But the way it works with the Arduino Uno, the way it communicates data with Arduino Uno is through serial communication. So we have talked about serial communication in our previous videos as well, and now it will play a huge part over here. So the rest 5 pins are VCC, which is connected to plus 5 volt for powering the module. We have ground, which you will just ground with the Arduino. Next we have the RX and TX. So just recapitulate what we talked about and how the TX of the transmitter is connected to the RX of the receiver, and the RX of the transmitter is connected to the TX of the receiver. So we explained all of this and covered all of this in our introduction to serial communication, and that is how we will be interfacing these 2 pins with the Arduino Uno. Next we have our state pin, which is basically used to check the functionality of the module by connecting it to the onboard LED. We also have the onboard LED on the HC05 module. The HC05 module also has an onboard LED, and the function of that is that whenever it is blinking at a really high speed simultaneously again and again, that means that no connection has been established with the HC05 module. But as soon as you establish a connection, it blinks in intervals of 1 second, which shows us that okay, the connection has been established. So on your screen right now, you can actually see the circuit diagram of the Arduino Uno with the HC05 module, and you can clearly see here how we have connected the VCC and ground to the Arduino Uno. And for the RX and TX pins, we have connected the TX of the HC05 module to the RX of our Arduino Uno, which is basically pin number 0. And we've connected the RX of our HC05 module to the TX of our Arduino Uno, which is digital pin number 1. So now here we are in the Arduino IDE after creating the whole application, after talking about the HC05 module and the way it functions and its pinout as well, learning about the circuit diagram. Now we are at our final stage where we will be writing the code. So what is the plan of action is that once we have sent the on from our app, we have configured it that every time it sends on, it will basically send A, the character A, to our HC05 module. Next, the HC05 module will be serially communicating this character to the Arduino Uno. So after the Arduino Uno receives this very character, we have to turn on the onboard LED. So just remember how in our introduction to serial communication lesson, we wrote a program where we turned the onboard LED on and off using our serial monitor. So when you really think about it, the code is going to be exactly similar. You may ask why. This is because when we were using the serial monitor, we were establishing serial communication, and via serial communication we were sending characters A and B. And in the program, we have programmed that every time you get the characters A and B, you turn the onboard LED on and off. In this case also, we are doing the exact same thing. But instead of the serial monitor, we are using the HC05 module to give that very data, to give those very characters through serial communication. So the code is just going to be the same. However, let's actually write it down once again. And writing it again will obviously improve our understanding of the code. First of all, set up the onboard LED. So in order to do that, I will be writing pin mode 13 as the output. I will also turn off the onboard LED in its initial stage. So digital write 13 low. Next, what I'll be doing is I'll be initializing serial communication. So serial.begin at 9600 baud rate. So that is what I've done here. With this out of the way, our setup function looks good. Now in the loop function, we are going to use the same very concepts that we used our introduction to serial communication lesson, where we will write while. We'll be using the while loop, while exclamation mark serial dot available which means, okay, if our serial communication has been set up, next we are going to write if serial dot available is actually greater than 0, right? If the data that we are actually getting some kind of data here. Up until this moment, what we did is that we are going to stay at this very statement if no serial data has been received, and we're going to execute this very statement. We're going to go in that if loop if we are getting some kind of data. So now what I'll be doing is I'm going to be storing that data in a variable temp. So in order to do that, I'll be also declaring a variable temp. So why we're declaring char temp is because we are actually getting a character from our MIT application that we just created. So temp is equal to serial dot read, and if at any point of time you feel that this code is not really resonating with you at of this moment, just go to our introduction to serial communication lecture, just see that again. I mean, after you do that, it will be crystal clear. Next, we want to have our statement, the if statement over here, that okay, if temp is equal to a, that is what we programmed our app to send every time it wants us to turn on the LED, right? So that's what I'm doing here. If temp is equal to a, so I'll just be writing parenthesis here. I will be writing digital write 13 as high, and similarly just copy paste the statement that okay, if temp is equal to b, I want this to be low. So that is the entirety of our code, and honestly it looks really good. So we'll just verify it, and we have no errors. So one major thing will be that when we are actually uploading this very code to our Arduino, if the HC05 module has been connected, which means that the RX and TX pins have been attached, we will get an error. So over here we have to be very careful that the RX and TX pins have not actually been interfaced with the Arduino while we are uploading our code. This is a word of caution which is very important, because the code will not upload until and unless the RX and TX have been removed from the Arduino, the RX TX pins connection.